Hello and welcome to today's lesson. In today's lesson, we will be talking about scale factor of enlargement as part of SHS2 enlargement and similarities. Before we move on to the main topic, let's revise what we learned last week. Now, last week we looked at some questions involving how to find the scale factor of an enlargement when the coordinates of a point and its image are given. In this question, given that A prime with the coordinates -10, 2 is an image of the point A with the coordinates 5, -1, after an enlargement from the origin, what was the scale factor of enlargement? You can pause the video and try your hands on this question and post the answer in the comment section below. Now let's look at the solution. Remember that in order to find the scale factor, we need to divide the coordinates of the image by the coordinates of the object. So in this case, we can label the coordinates of the object as x1, y1, and that of the image as x2, y2. And we'll then divide the corresponding coordinates. So I can use the x coordinates to find the scale factor, whereby I'll divide x2 by x1, and that is -10 divided by 5, which gives me -2. Alternatively, I can also use the y coordinates, that is dividing y2 by y1, that is 2 divided by -1, and that also gives me -2. So the scale factor of enlargement was -2. We also looked at how to find the total surface area and volume of prisms. In this question, we are being asked to find the total surface area and the volume of a cube that has a length of 5 centimeters. You can pause the video and solve the question. In the solution, we have a cube and the length, the width and height of the cube are the same. So if the length is 5 centimeters, it means all its dimensions are also 5 centimeters. So to find the total surface area, we use the formula 6L squared. That is 6 times the length again. So in substituting the length, which is 5 centimeters, we have 5 squared, that gives us 25 centimeters squared. Then we multiply it by 6, and that gives us 150 centimeters squared, or squared centimeters, and that is the total surface area of the cube. We can also find the volume of the cube by multiplying the length by itself 3 times, that is L times L times L. So that gives us 5 times 5 times 5, and that gives us 125 cubic centimeters as the volume. Let's move on to today's topic. We are talking about scale factor of enlargement. In this lesson, the students will be able to describe the characteristics of enlargement under various conditions of a scale factor, find the scale factor of enlargement in scale drawings, and establish the relationship between the areas and volumes of similar plane figures and solids and their images. Now, what is a scale factor of enlargement? The scale factor of enlargement, which is denoted by the letter K, refers to the ratio of lengths in an image to the corresponding lengths in the object after an enlargement. The scale factor of enlargement can be a positive or a negative whole number, or it can also be a fraction. The scale factor is used to multiply the dimensions of an object to determine the characteristics of an enlargement. In other words, the scale factor will determine the size of the image after an enlargement, and it will also determine the position of the image after an enlargement. Now let's do this simple activity using a GeoGebra artifact, whereby we will be describing the characteristics of an enlargement, and that will be based on the conditions of the scale factor of enlargement. So let's go ahead and open our GeoGebra window. In our GeoGebra window, we have this artifact where we have a slider, and we have the object triangle, we have the center of enlargement, and then we also have the image. So we are going to move the slider and adjust the scale factor, and for each adjustment we are to indicate the size of the image and also the position of the image with respect to the center of enlargement. So now in filling this table, for example, we have a scale factor of less than -1. So in our GeoGebra window, for example, we have a scale factor of -2, and we can clearly see that the image size has been enlarged, and the image is formed at the opposite side of the object with respect to the center of enlargement. So we can fill this table by saying that the size of the image will be enlarged. So we can say that the size of the image is enlarged. And then with respect to the position, we would say that it is at the opposite side of the object. Okay, so now you can go ahead and open your GeoGebra window and adjust the slider, and for each adjustment you complete the table. So in this case we have a scale factor less than -1, and when we have the scale factor to be equal to -1, you would notice that the image size is the same as that of the object, and still the image is at the opposite side of the object with respect to the center of enlargement. When the scale factor is between -1 and 0, for example, a scale factor of -0.5, we would notice that the size of the image has been reduced and it is still at the opposite side of the object with respect to the center of enlargement. Now, if the scale factor is equal to 0, no image is formed. When the scale factor is between 0 and 1, for example, a scale factor of 0.5, we would notice that the image size is reduced, and now the image is at the same side of the object with respect to the center of enlargement. When the scale factor is equal to 1, you would notice that the image has the same size as the object. In other words, there is no enlargement, and the image is also at the same side. In fact, it is at the exact position of the object. And when the scale factor is greater than 1, for example, a scale factor of 2, you'll notice that the image size is increased and it is at the same side of the object with respect to the center of enlargement. So you can go ahead and fill this table in activity 1. If you filled your table, you would have results similar to what is observed here. In summary of activity 1, we can say that if the magnitude of the scale factor is greater than 1, then the enlargement will result in an enlarged image, or an image with an increased size as compared to the object. If the magnitude of the scale factor is between 0 and 1, then the enlargement will result in a reduced image. If the scale factor is positive, if both the object and its image are on the same side of the center of enlargement. Then the scale factor is negative if both the object and its image are on opposite sides of the center of enlargement.